Mixtures can be of two types, homogeneous and heterogeneous. A homogeneous mixture is a mixture which has a uniform composition throughout its mass. All parts of a homogeneous mixture have the same properties like color, taste, and smell. A heterogeneous mixture is a type of mixture which contains physically distinct parts and has non-uniform compositions. We take some water in a beaker and dissolve some amount of copper sulfate in it and observe what happens. We find that the solution becomes light blue in color, which is uniform throughout. The same happens when we dissolve crystals of potassium permanganate in water. The solution turns purple in color. This purple color is uniform throughout the solution. This means that it is a homogeneous solution. Now if we take another beaker and add double the amount of potassium permanganate to it, what do we observe? We observe that the purple color in this solution is more than the intensity of purple color in the previous experiment. Let us now learn about the difference between homogeneous and heterogeneous mixtures. Homogeneous mixtures are those which have a uniform composition throughout its bulk. They do not contain physically distinct components. Homogeneous mixtures are called solutions. On the other hand, heterogeneous mixtures have a non-uniform composition. They contain physically distinct components and are called either colloidal solutions or suspensions. Mixtures can be classified into three categories based on the particle size of their components. The three categories of mixtures are solutions, suspensions, and colloids. To understand the differences in the categories of mixtures, let us perform an activity. Take a small amount of copper sulfate crystals in a beaker. Add 100 ml water to it. Stir thoroughly with a glass rod until it dissolves and observe. We observe a clear light blue colored solution of copper sulfate. The clear blue solution indicates that the copper sulfate crystals have broken down into extremely small particles, which are no longer visible. When a beam of light is directed through the beaker and observed from the other side, the path of the beam of light is not visible. This observation shows that the particles of copper sulfate and water are too small to scatter the light. Light just passes through the copper sulfate solution. This copper sulfate solution is an example of homogeneous mixture and is termed as a solution or true solution. Let us now perform a second activity. For this, we take some sand in a beaker. To it we add 50 to 100 milliliters of water. Next, we stir the solution thoroughly with the help of a glass rod and allow it to stand undisturbed for few minutes. We observe that the sand does not dissolve in water, but remains suspended in it. After a few minutes, sand settles down at the bottom of the container. From this observation, we can say that this is a heterogeneous mixture. Such heterogeneous mixtures are called suspensions. Let us now perform one more activity. Activity 3. We take a spoon of milk in beaker containing water and stir thoroughly with a glass rod. We find a turbid white solution of milk in water. In this case, individual milk particles cannot be seen. It means that particles of milk are too small to be seen with our eyes. However, if a beam of light is passed through this milky solution, the path of the beam of light becomes visible. This shows that in milk, the fat particles are big enough to scatter the light. These types of mixtures are heterogeneous and are called colloidal solutions. Let us now come to the conclusion. From the activities performed, we conclude that the size of the particles in true solutions is too small to be visible. The size of particles in colloidal is also small, but bigger than particles of true solution. The colloidal particles are big enough to scatter the beam of light. On the other hand, particles of suspension are big and can be seen with the naked eye. Size of particles in suspensions are greater than size of particles in colloidal solutions are greater than size of particles in true solutions. This can be verified by the process of filtration. The suspension of sand obtained can be easily separated from water by using apparatus as shown in animation. When we pour sand and water mixture through a filter paper placed in a funnel, the sand collects in the paper while water flows through. This is because sand particles are much larger in size than the pores of filter paper and cannot pass through. The colloidal particles in colloidal solution cannot be separated from water by filtration. This is because the size of colloidal particles is small and they can pass through the pores of filter paper. Similarly, the particles of true solutions cannot be separated from water by filtration. This indicates that particles of true solutions are extremely small. In a true solution, like sugar solution, the dissolved particles of sugar are extremely small and easily pass through the pores of the filter paper. A solution is defined as a homogeneous mixture of two or more substances. It has the same composition throughout their bulk. The substances present in it are called its components. The components can exist as solid, liquid, or gas. A solution is produced by dissolving a substance in another substance. The substance that dissolves is a solute. The substance that the solute dissolves in is called a solvent. If the solvent is water, the solution is called aqueous solution. Metals can also have solid solutions. They are also known as alloys. Alloys can be formed by the combinations of either metals with metals or metals with non-metals. Let us study the arrangement of atoms in metals. Most metals are solid. Pure metals are made up of the same type of atoms and are of the same size. The arrangement of the atoms in metals gives the metals their ductile and malleable properties. The orderly arrangement of atoms in metals enables the layers of atoms to slide on one another when force is applied. Thus, metals are ductile or can be stretched. Most pure metals are weak and soft. The aim of making alloys is to improve their properties by making them stronger, harder, resistant to corrosion, having a better finish and luster. An alloy is a combination of metal with another, so as to improve the properties of the base metal. Alloys are made of different types. An alloy can be formed by combining a metal with other metal. magnesium is formed by 75% to 85% aluminium and 15% to 25% magnesium. Metals combine with nonmetals to form alloys. Let us take the example of pure gold, that is 24 karat gold, which is soft and weak. Now, to make ornaments out of it, its strength and hardness can be increased by making an alloy of 22 karat. We can also have an example of a solution of a gas and liquid. Soda water is solution of carbon dioxide in water. It has uniform composition throughout, as carbon dioxide is uniformly distributed in water. Let us discuss examples of various types of solutions. Kinds of solutions. Gaseous solutions. Gas in gas. Air, nitrogen, oxygen, carbon dioxide, etc. is a solution of several gases. Liquid in gas. Damp air, moisture in air. Liquid solutions. Gas in liquid, carbon dioxide in water. Liquid in liquid, vinegar in water. Solid in liquid, salts dissolved in water, sugar in water. Solid solutions. Gas in solid, hydrogen gas trapped in palladium metal. Liquid in solid, benzene in rubber. Solid in solid, copper in zinc. Brass is made of 70% copper and 30% zinc. Properties of a solution. Solutions are homogeneous mixtures. The particles are extremely small and cannot be seen with naked eye. The particle size of solutions are smaller than 1 nm or 10 to the power minus 9 meters. Particles in solution are unable to scatter light passing through it. The path of beam is not visible when a beam of light is passed through the solution. Particles are evenly distributed through the solvent. This is because composition is uniform. Now, let us try to define what a suspension is. A suspension is a mixture of two substances, one of which is finely divided and dispersed in the other. Examples of common suspensions are sand in water and dust in air. The particles in a suspension are larger than those in a solution. They are visible under a microscope and can often be seen with the naked eye. Particles in a suspension will settle down if the suspension is allowed to remain undisturbed. Many particles of a suspension can be separated through filtration. We will now try to understand the difference between a solution and a suspension. We take water in two beakers labeled as A and B. We add a spatula of copper sulfate crystals into the beaker A and a spatula of chalk powder into the beaker B. We then stir the contents of the beaker well and observe the appearance of the mixtures. When we dissolve a solute in a solution, its particles are separated from each other and dispersed evenly throughout the solvent to such an extent that the solute is no longer visible to us. Such solutions are always homogeneous or uniform in color and appearance. The mixture in the beaker A is a solution, whereas the mixture in the beaker B is a suspension. When we filter the copper sulfate solution, we find that no residue is left on the filter paper. When we filter the suspension, residue is left on the filter paper. Liquid collected from the filtration is called the filtrate. The solid collected on the filter paper is known as the residue. It allows light to pass through it. When a suspension is left to stand, its particles will either settle at the bottom or float at the surface. The suspended particles are left behind as residue during filtration. A colloidal solution consists of small solute particles spread evenly in the solvent. The size of the particles in colloidal solutions is much smaller than the size of the particles in suspensions. True solution is defined as a mixture of particles of solute evenly spread throughout the solvent. Dispersing medium. Properties of colloids. Brownian movement. The random motion of the dispersed particles in a colloidal dispersion is known as Brownian movement. It results from the impact of the particles of the dispersing medium on the colloid particles, leading to haphazard motion. Tyndall effect. The Tyndall effect is observed with colloidal dispersion but not with true solutions. A beam of light passing through a colloidal dispersion kept in a beaker in a dark room will be visible at right angles to the path of light. This effect is called Tyndall effect, and it is due to scattering of the beam of light by the colloidal particles. Colloidal particles carry charge. The movement of colloidal particles under the influence of external electric field is called electrophoresis. Type of colloid. Solid solution, colored glass, gemstone, sol. Paints, muddy water, ink, detergent, rubber, aerosol, smoke, dust, gel, cheese, butter, jellies, emulsion, milk, hair cream, cosmetic lotion. Aerosol, fog, mist, cloud, insecticide spray. Solid foam, pumice stone, foam rubber. Foam, froth, whipped cream, soap lather.